Hello, ladies and gentlemen. I'm going to be working with Pre-Calculus Unit 1, Topic 2. So this is from the review packet, although there are some problems that are slightly different than what are on this one I'm going to be going over. But for the most part, I'm going to be going through each one of these problems. I think some of the problems were actually crossed off, but I still plan on going through all those types of problems, just making sure that you have somewhat of an idea of how to do these types of problems. And for the most part, if you do have an understanding of my work and kind of how I'm organizing um, these problems, then you should be good for the progress check. Okay, so it says circle the expression that is equivalent to log base, and if there is no number, that is in a sense going to be a log base 10. So if there is no specific number there, it is a log base 10. So we want to say log of 4a to the third over b. And so what this is dealing with, either condensing or expanding. And in this case, we are going to be expanding. So whenever we have some type of multiplication, we expand it by addition. So what do I mean by that? So log base or log base 10 of 4. And since there's a multiplication between the 4 and the a, we're going to write a plus sign and then rewrite another log of a to the third. And then when I'm doing division, that will be subtraction. So that would be log of 4. Now, it's very tempting on saying that this is going to be my answer. In fact, there is actually no answer dealing with this. So also another thing to take note, if you do have an exponent in a log, you can bring it down in front, which usually deals with expanding as well. So I would write this as log of 4 plus 3 log of a minus log of b. And that would be my answer. So kind of taking a look at some of the answers, that would be letter B. Now, one of the misconceptions when dealing with these types of problems is if you were to have something that looks like this, not log of A over BC. Now, a lot of people will end up doing one of these things. They'll say log of A, and then they'll see that there's multiplication between the B and the C. So they'll say minus log of B, and then plus log of C. Well, this is technically wrong. The reason why is because the C is in the denominator as well with B. So when I'm dealing with that subtraction piece, it's saying that both of these values end up having a negative exponent because they're both in the denominator. So the answer to this would be log of A minus log of B minus log of C. So just something to kind of take note. All right, number 2, it says evaluate each of the logarithmic expressions. So this is the whole base of the answer equals the inside. So I like to kind of do a box there. So I say base, which is 2, to the answer equals the inside, which in this case is going to be 8. And we can kind of think about this number. So 2 to the first is 2, 2 to the second is 4, 2 to the third is 8. So the answer here is 3. And we would write 3 as my answer. Okay, next one. 2 to the box equals 1/2. So since I know that is a fraction, it's going to be some type of negative, right? Because if I say 2 to the first is equal to 2, 2 to the 0 is equal to 1, and 2 to the negative 1 is going to be equal to 1/2. And the reason why is because it's dividing by 2 as you're going up. So the answer here is going to be -1. All right, next one. 25 raised to the something power gives me 5. Okay, so with this problem, I need to think about what exponent will make it a little bit smaller. Now, I do know square root of 25 is equal to 5. So if I write this as 25 to the 1/2 power, that will give us 5. So the answer is 1/2. Lastly, 7 to the something power gives me 1 over 49. So there's a bunch of things that are happening here. I know 7 to the second is going to give me 49, but how do I get it on the bottom? So I would write 7 to the -2, and that would give me 1 over 49. So it would be -2 is your answer. Number 3, so write the inverse of the function f of x is equal to 10 plus e to the x and state the domain of the inverse. Now, something to kind of keep in mind, if we're talking about the domain of the inverse, that's really the range of the original. So if I think about how this works, right, e to the x. E to the x looks like this. It's an exponential function that has a domain that is all real numbers. but then the range goes from 0 to infinity. Now this 10 piece, right, that means that we're just moving it up 10 units. So if this is 1, this is now going to be at 11. So I end up getting a graph that looks like this. And my horizontal asymptote is going to be at y is equal to 10. So that means that the range here, the range of the original, is going to be from 10 to infinity. Now, it's also a parentheses because we're not including 10 because there's an asymptote at y is equal to 10. So I can actually write that down as the domain for the inverse function, because that's like saying that both of those things are flipped. So the domain of the inverse is really the range of the original, and the range of the original, or excuse me, and the domain of the original is going to be the range of the inverse, right? They're just flipped. All right, so how do I find the inverse function? So I'm going to write f of x equals 10 plus e to the x. So to solve this, I'm going to just do it in terms of y. So y is equal to 10 plus e to the x. Switch the variables. X is going to be equal to 10 plus e to the y. And what I want to do here is I want to try and solve for y. So it means bring it down and some other things. So I'm going to start off by subtracting 10. So I'm going to get x minus 10 is equal to e to the y. Now, how do I undo, in a sense, that e and bring down the ln? Or excuse me, bring down the y. I just kind of said what it was. And what we're going to do to both sides is we're going to do ln to both sides. Now, why am I choosing ln? Well, ln of x is the same exact thing as saying log base e of x. So what it's going to do is it's going to actually cancel with the e and bring down the y. So I'm going to write ln of x minus 10 is equal to y. So that is going to be my inverse function. So I can write this as ln of x minus 10. And since I already did the domain, that should be fine. Okay, so write a rule for the function h of t given the values of the table below. A couple things to take note. So we know that it is undefined at 0 when t, or excuse me, yeah, when t is equal to 0, it is undefined. Okay, so I also notice right here that this is going up by multiplying by 4. Multiplying by 4. But notice how this is normally my x, that is my y value. So the x value is normally going up by 1 each time. So right off the bat, I know that this is going to be a logarithmic graph. Because normally when we're dealing with a logarithmic graph, usually the y values go up by 1. The y values go up by 1, so 0, 1, 2, 3, 4. And the x values go up by whatever's being, in a sense, multiplied with these values. So we normally have 1, and then it depends on the base that we're working with. So if this goes 4, 16, 64, 256, I'm trying to think about what log base blank of x is that going to be. And in this case, since we're multiplying by 4, it is going to be log base 4 of x. So if it's being multiplied by 3, it would be log base 3 of x. If it was being multiplied by 10, it would be log base 10 of x. Okay, and just to double check, if I were to say log base 4 of, let's say, 0, what would that give us? So I'm saying 4 to the something power gives me 0. And since that's not available, this will be undefined. Let's do log base 4 of 1, and that would actually be 0. Log base 4 of 4, which would be 1. Log base 4 of, let's do 16, that would be 2. And so it seems like that those values end up working out just fine. Okay, working with number 5. It says graph y is equal to f of x. So I'm really trying to say graph this specific value, indicate at least 2 points on the graph. Graph the asymptotes using a dashed line. Now what I'm going to do is I'm going to graph the original if it was just log base 3 of x. So I'm going to say that that will be g of x. I'll also do this in kind of like a highlighted green, but I'll also start off with blue. So that would be, in a sense, this graph. So I go 3 over 1 up. No, that's not right. That would be 4. Right, because if I ended up doing log base 3 of 3, that would end up giving us 1. So 3, 1. So there, right there is going to be my graph. Okay, and like I said, I'm going to highlight it in green. So this is my original graph without doing the +2. Now, what the +2 is really saying on the very end, shifting it up 2 units. So I'm going to take each one of those points and shift it up 2 units, 2 units. I still end up having a vertical asymptote at x equals 0. So I end up getting a graph that looks like this. And you can always use Desmos to double check your work, especially if you're actually working with this type of problem. At home, so that you can kind of get a better gist of how this problem works. So the red is my y is equal to 2 plus log base 3 of x. Then it says evaluate f of 1/3. So I'm going to write this as f of 1/3 equals 2 plus log base 3 of 1/3. Now remember, base to the answer equals the inside, so base to the answer equals that 1/3, and then we'll worry about adding 2. So in this case, this is going to be -1. So I'd write f of 1/3 equals 2 plus -1, so that would be at 1. So that means at 1/3, so roughly there would be a point right there. My sketch isn't exactly the best, but we could say that the value will be equal to 1. Okay, so then it says find the inverse at 6. So what I'm going to have to do here is I'm going to actually have to figure out what is the y value, because if I'm saying this is my inverse, this is normally my x for the inverse equation, I'm really saying, okay, let's plug into the y of the original function, because remember, they're switched. So if I really did this as 6 equals 2 plus log base 3 of x, subtract 2, so I end up getting 4 is equal to log base 3 of x. Now base to the answer equals the inside, so base to the answer equals the inside, x would be equal to 81. So that means that this evaluation is going to be equal to 81, because this in turn is going to be the y value of the inverse, because they're switched. Now, you could technically write out the inverse equation for that and then plug in 6, but you're going to end up spending more time kind of working out those problems. So if you have a good idea with understanding how inverses work, right, x becomes y and y becomes x, right, you can just sometimes get lost with this idea of which one's my x, which one's my y. So the important thing is to keep that, you know, making sure that you're able to keep those intact. So explain why f of x can be expressed as f of x is equal to log base 3 of 9x. So I can write this as, if I were to kind of split these up, I can write this as log base 3 of 9 plus log base 3 of x. So that dealt with the first problem if I were to be expanding. And then I can also rewrite this log base 3 of 9. So 3 to the what power gives me 9? And that's going to be 2. So 2 plus log base 3 of x. And that is why that could be, in a sense, written that way, because I can just express it by expanding it. Now it says explain why f of x can be expressed. So there, like we've kind of been saying, there can be multiple ways of expressing these types of problems. So I'm going to write this as, so the only difference here is this part to this part. Now this seems really, really kind of confusing, but way back in the day, we did this change of base formula. So change of base. So what I could do here is I could actually write this as log of x over log of 3. And really, there's another version of this. So this is really saying a log base 10, isn't it? So actually I could do this with any type of base. So I can also do it with ln, which means that that's a log base e over ln of 3. And in a sense, that's what this is. This is just really writing it a different way. We would just write this as 1 over ln of 3, because that's dealing with change of base, multiplied by ln of x, right? This piece is really that, and this piece is that, right? They mean the same thing. Plus 2 is equal to f of x. So that's how you can kind of explain how those are equivalent because of the change of base formula. All right, hope you enjoyed this video. If you have any comments, please comment below. Please also comment on my Discord server. I'll have posted in the description. And if you have any other questions, just feel free to let me know. All right, thank you.